My name is R. Crosby Lyles, and this is News from the Can. So right off rip here, I want to get straight to it. The reason I'm making this video is because back in March 26, 2021, I put up this video right here in Inconvenient for Everyone, which shows Camps Copernicus going to the 500 hectopascal level, which is about 18,000 feet. I may have misstated that in some recent videos. I got, mixed up about how high up it is. I know that it's at about 18,000 feet, roughly. They use 500 hectopascals to measure geopotential height, which is good for being able to see the different movements of air masses. Very convenient for that. A hectopascal is 100 pascals. They use pascals because it's the System International unit. It's the metric system unit for pressure, but it's really sort of the lab measurement. The reason they use the term hectopascal is because when you hear the term hectopascal, you know they're going to be talking about something having to do with chemistry. Because a pascal is a very small change, very tiny change in pressure. So they're going to use pascals they use it for all kinds of stuff, but typically it's for scientific measurements of shear strength, tensile strength, things like that. Pressure having to do with work in the lab, they'll use pascals. So that they're talking about, when you hear pascals, they're talking about atmospheric chemistry, because a hectopascal is 100 pascals is equal to 1 millibar. And 500 millibars or 500 hectopascals is about halfway up the atmosphere in terms of pressure. And but millibars, they'll use millibars in the United States at least to let you know that they're talking about weather. Sometimes they'll use, I've seen them use inches of mercury or millibars. Occasionally you'll see somebody referring to something having to do with a storm coming, and they'll still use hectopascals. But typically when they're talking about weather, they're going to use millibars. And it's just sort of like I don't know if it's an unspoken thing or a convention or what, but that's typically what it is. So anyway, that's that. A hectopascal is a millibar. So a bar is about 1 atmosphere. An atmosphere is a little over a bar. So 500 hectopascals, 500 millibars is about halfway up the atmosphere. And so it's a convenient spot to measure certain things. So anyway, here's your measurement, and this is at 18,000 feet, and this is back in March 26, 2021. There's a narrative here about polar amplification because of this CO2 at a lower level than 50 hectopascals, which is up in the stratosphere. But today, this is what it looks like. That's a lot different. So you can see this is 500 hectopascals. There's the legend, which is 1,000 parts per million. It goes up to 1,000 parts per million. But okay, what's really important to notice here is that the number right before the 1,000 parts per million is 418 parts per million, right here. And then the next number is 1,000. This is important because on my phone, which is depicted in this, right, just pulled it up. You can see on the screen there, I've got it up. This is 1,000. Million there. I pull the phone up. 600 parts per million. And the phone says 600 parts per million. So this entire clip right here will be on the back end of this video, so you can see that I'm not jerking around here. I got my other camera out. I got my Sony camera over there. I pulled it out because this is on my phone. You can see 600 parts per million, and this does this every now and then. If I take this phone and reboot the page, then it'll revert back to 1,000 parts per million. Now I'm not really sure how to interpret that little game that's being played there, why they do it like that. Some people are probably seeing the 600 parts per million, and some people are probably seeing 1,000. It's not really, but really important here, it's not really that important. Why? Because the second to the last number is 419 on the phone, and the second number on the computer is 418. So the data, what you're looking at color-wise, the data is pretty much the same. I'm not really sure why they use 1,000 parts per million there. I think that's because of some consideration about error. That maybe it could be higher in some places, and I'm not really sure. But it's a bizarre, it's been a question for a long time. I've had videos that I've made about this, and the bottom line with it is the second number is not different. This is 418, the other one's 419. But basically what that means is that it's the same data. The data hasn't changed. It's just for some reason that number changes. On the computer at this particular moment, it's 1,000, and on my phone, it's 600. On my phone, it's 600, but see that second to the last numbers, and it's virtually the same. And furthermore, as I said in my last video, it's not 300 or 350. And 350.org, anybody remember 350.org from years ago? Well, we blew past that, so you might want to name that something else now. Maybe call it 600.org or something. And this shows you right here on the phone. Also shows you the same. You're looking at the same map, essentially the same data. The data is the same, it's just that the legend is different. And why that's important, it's important to somebody who's trying to engage in fuckery. And so, again, they might just be shunting that to my phone, right? It looks like fuckery maybe, or who knows, really. But I just got to throw that out there in case you look on your phone and you see, or you look on your computer and you see 600 parts per million. Doesn't matter. The data is essentially the same because the second to the last number is still 418. So, and it's whether it's a conspiracy or not, doesn't really matter. It's greater than 350. So we passed 350.org. Forget about it. Now, having said all that, this is May Beetle Death Zone update. This is on the 12th of July. So you can see it's better than, this is Inconvenient. This is 500 hectopascals. 500 hectopascals. They got the 1,000 legend there, but you can see it's a lot worse. This is in March. You're coming off the winter time. It would make sense for there to be an accumulation of CO2. By July 12th, it's a little bit less, and damn, by August 4th, it's even less with some green showing through, which is green is back here below 400 in some of these remote areas. If I let it play, you can see here's a little piece of green floating by Iceland, like it's part of a swirl coming off of the Baffin Island or the Baffin Bay area, which is fascinating. A lot of forest fires up in Canada. There's forest fires up in Russia. So let me click through this current events wise. Firefighters battle more than 100. This is Russia, and Athens is on fire currently. Prayers going out to all the folks out there. They had some bad fires last year, I guess. Some people got killed in Italy, and so that's serious shit. Meanwhile, in Brazil, this is a day ago, but potent Antarctic outbreak brings rare snowfall to much of Brazil, and Brazil is like subtropical. This is tantamount to snow in Florida, essentially, because it's right around, it's maybe a little bit below the Tropic of Capricorn, whereas up here where this is the Tropic of Cancer. So there's that. And this is rare, and they got a lot of snow. Not just a little bit. They had Amazon has had, Brazil has had floods, and if you've been paying attention to the weather over the past 3 or 4 months, not even 6 months, 3, 4, 5 months, somewhere in there, Brazil has flooded, Italy has flooded, serious, like 100-year floods. Germany has flooded. That's probably the best known, but Italy also flooded. I think some parts of Arabia, Saudi has flooded recently, I'm pretty sure. Might want to double check that. And maybe Iran and Turkey. I think Turkey flooded recently. Japan had a big landslide happen and stuff like that. So it's going on out there. Sweden, I think, is it Sweden? I'm sorry, Norway. Norway flooded. So it's breaking off, and at the same time you have droughts. This is all climate change type of stuff. But ultimately, I'm looking at this, and I'm like, okay, well, that's a big difference between March and today. So what the hell's going on? This is my hypothesis. And as I'm thinking about my hypothesis, and I just happened to see this in my suggested videos while I'm thinking about what the hell's going on with CO2. Tran Nguyen over at NCAR is on the NCAR Atmospheric Chemistry and Observation and Modeling channel. It's wonderful that they put this stuff up. So I always like to source the folks at NCAR and UCAR and the National Weather Service, the real people, because that's where you want to get your actual no bullshit analysis from. I defer to these folks to do the actual analysis, and that's what this is not necessarily everybody's cup of tea. Tran Nguyen has, I guess, has a doctorate in, I'm not sure if it's atmospheric chemistry. It's not atmospheric chemistry. But it's chemistry. And they're talking about isoprene-derived aerosols. Now, and I'm like, okay, well, maybe because of all the fires. Because immediately my thought was, well, damn, that's a big drop in carbon dioxide over a few months. We're having a lot of fires. Is it possible that, that one of the things that fires produces is formaldehyde? So I'm not really sure about an interaction there. And the other thing that we've had recently is a very active volcano in Iceland. So the first thing that popped into my mind was, is there an interaction with hydrogen sulfide that would mitigate carbon dioxide? When you react carbon dioxide and hydrogen sulfide, you get an organic compound, like a sulfone or something like that. It's pretty complicated. But, hydrogen sulfide is pretty reactive. It's a deadly gas. That's why you want to be wearing a mask around that. And I cannot pronounce the name of that volcano to save my life. But anyways, you've seen it already. Not much happening over there at the volcano, but it's steaming off gases still. I guess that's an activity chart there. So my first thought was, yeah, maybe it's hydrogen sulfide, but we're talking about all the way around. This is something that's going all the way around the Arctic Circle. So there's that, and then there you have forest fires also. And so what are the possible what are the possible interactions there? And then I happened to see this video in my suggested videos, and it's like, isoprene. Isoprene are 2-methyl-1,3-butadiene. I'm not sure what that is. Butadiene is a common organic compound with the formula CH2 double bond C. In its pure form, it is a colorless volatile liquid. Isoprene is an unsaturated hydrocarbon. It is produced by many plants and animals, including humans, and its polymers are the main component of natural rubber, C.G. Williams named the compound in 1860 after obtaining it from thermal decomposition, pyrolysis of natural rubber. He correctly deduced the empirical formula C5H8. Natural occurrences. Isoprene is produced and emitted by many species of trees. Major producers are oaks, poplars, eucalyptus, and some legumes. Yearly production of isoprene emissions from vegetation is around 600 million metric tons. Yearly production of isoprene emissions by vegetation is around 600 million metric tons. Half from tropical broadleaf trees and the remainder primarily from shrubs. This is about equivalent to methane emissions, and accounts for around 1/3 of all hydrocarbons released into the atmosphere. In deciduous forests, isoprene makes up approximately 80% of hydrocarbon emissions. While their input is small compared to trees, microscopic and macroscopic algae also produce isoprene. Very interesting. Plants, isoprene is made through the methyl erythritol 4-phosphate pathway. Isn't that the same shit that's in my stevia? And I looked at that and I'm like, and like they make artificial sweetener out of coal tar, and shit like that. Which stevia is something completely different. It's not the pink stuff, whatever the hell that's called. Saccharin, sodium saccharin, is not erythritol. Erythritol is, I think that's the same stuff that's in stevia, but they add it to stevia for some reason. But I think it comes from the stevia plant. But anyway, not to get into the ugly details on this, but it says isoprene emission increases dramatically with temperature and maximizes at around 40 degrees C. So one of the things that Dr. Tran, I think she's a PhD, is getting into here, oxidation of isoprene-derived aerosol compounds as sources of formic and acetic acids. So with all the forest fires that are going on, is ash itself that is being drawn into an aqueous solution in the cloud droplets, is that forming a base that might absorb CO2 naturally. In other words, is it possible that forest fires, the product of forest fires, whether it's isoprene-derived aerosols, because you can see all of the different stuff that's being produced here, is it possible that that's drawing carbon dioxide out of the atmosphere? And the only reason I ask is because you can sort of empirically see that carbon dioxide has gone down at the 500 hectopascal level. Could be, precipitation is possible. Heavy amounts of precipitation could draw down that carbon dioxide. That's a pretty big drop. And so the situation is always fluid. Now, what's not going to change, interestingly, and it was a surprise to me when the first time I ever saw this, is at the 50 hectopascal level, which is about 67,000 feet. This is up in the stratosphere, where we have an accumulation of carbon dioxide. So there's a guy that I went back and forth that I left a comment, and the guy went crazy on me. But he didn't understand the subject of my channel. There's a certain amount of forgiveness, and the guy lives in Canada, up in the Bear Lake area or something like that. He's like probably a tar sands guy. Yeah, I don't know, maybe. But anyway, he was he was complaining about the legend at Copernicus. At the Copernicus Atmospheric Monitoring Service. And to me, it's like, if you want to really split hairs, but it's greater than 350. Yeah, it might not be 1,000 parts per million, but it's a lot more than 350 parts per million, which was like the drop dead cutoff from years ago. And I'm not trying to poo on the science or any of that kind of shit. You know what I'm saying? I'm not. I'm not a climate change denier or anything like that. You can see the rain. You can see all the rain events that we've had over the past, 4 months. 1,000-year rain events and shit. 1,000-year droughts and stuff like that. I mean, yeah, it's going on. And there's the carbon dioxide, and this is not going to get rained out. This is going to have to dissipate on its own. Now, having said that, this image is from the 27th of November. This is mid-shutdown, the last shutdown back in November of 2020. November 27th, 2020. So you can see, now this is also at the 50 hectopascal level. That's a lot less. So that mechanized shutdown of the world dissipated the CO2 in the stratosphere that much. Right? And now it's back up to this. This is July 17th, about a month ago. And now it looks like this. So from July 17th, what is that? This is July, from July 12th to today, it went from that to this. So industrial activity is obviously having an effect. My personal opinion, I always thought that this came from methane, and it probably does. That's probably a massive contributor. But my point was that it probably, because when you roll this beautiful bean footage here, you will notice that right around the summertime, and there are people at NCAR who have studied this between the 10 hectopascal and 50 hectopascal level. These zonal winds, this is called zonal winds, you'll notice that down here in the southern hemisphere, that the waves are moving to the east. But up here, they're moving to the west. So this means that the gas is moving from the pole to the equator. That's what it means to me. But these are zonal winds, and they change predictably every year. So those zonal winds in the northern hemisphere switch around from blowing east to blowing west at that level, to 50 between 10 hectopascals and 50 hectopascals. But that time, depending on what's in the atmosphere, what kind of greenhouse gas you have in the atmosphere, the time frame changes. And in one of my previous videos, I left a link, I think, and it's somebody somebody here at NCAR Atmospheric Chemistry Observation and Modeling. The link is in the description. It's somebody here, or it's somebody at NCAR UCAR that went into depth. And these are PhD people. I mean, these are the people. And this is Dr. Tran Nguyen here this is an award-winning scientist who is studying this stuff. So, but it's I don't know if it's kismet or whatever that I happen to get this notice in my suggested videos about isoprene-derived aerosol compounds. And could that have an impact on, because of all the fires and everything, could that have some sort of an impact on CO2 at the 50 hectopascal, or at the 500 hectopascal level? Because there's no green in that before. So, but yeah, these zonal winds, they regularly change direction every year, but there's a shift, and depending on how much greenhouse gas there is you can see that there's they have a sine wave where it shows you the change in wind speed, in kilometers per hour or per second, something like that. And so that wind change is related to a date, and that change will shift. But because of this is why I thought that it might be possible that methane, because years ago there was this whole bunch of methane coming off from sources up here in northern Europe and around the Arctic Circle. And that was my thought, that that's where this was coming from. But that may not be true because of the difference between these two levels. You know, this is, you know, back during the shutdown, it was less. It went down because it was more than that before. So it went from that, this is at the 50 hectopascal level, to this, and this is from, has to be because the lockdowns lifted and industrial activity went back to normal. So, and whatever, you know, I don't know if there was any change in farming practices or any of that, but maybe, perhaps. But we know that automotive traffic slowed down, and shipping traffic, it's like a logjam at every port, trying to get goods in and out of Asia and other places to get, you know, stuff delivered around the world. You got container ships just backed up in the canals across the universe. So anyway, there's that. So that's probably from, I mean, it's got to be. I mean, what else? It's got to be from industrial activity. And you bring in the fires and all that, and we're seeing a marked drop in the amount of carbon dioxide above, looks like the 40th parallel, somewhere in there. So whatever kind of knock-on effects that has, but also the rain, you know, I mean, rain in Brazil didn't take any of that. So something has to be causing that. And my thought, it probably has something to do with the forest fires. Probably. But there are a lot of fires, you know. There are tons of fires. If you look at the well, there's your aerosol forecast right there. Oh wow, yeah, holy shit. So yeah, maybe that there's having big forest fires up right there, where you see that big blob of aerosols. So and the nearest I can tell, you know, in all fairness, and I want to be fair. You know, I'm not out here. I'm not trying to push anything. I'm trying to find out, like everybody else. And how I got started in this was all the doomsday stuff, you know, the Venus Earth stuff, you know, to verify that. It's like, this is a pretty scary concept. And there are a lot of reasons why I don't think you really can get a Venus Earth per se. And my contention is that the Permian Triassic was not caused by carbon. It was caused by acid rain. It was caused by hydrogen sulfide and sulfur dioxide. But you can see this is the fire map here, fire activity, and most of it is in South Africa and across, you know, right across the equator. And again, greenhouse gas in the stratosphere does cause global cooling. Take a quick peek at the again, I want to I have to keep mentioning this. Forget about me. You can see for yourself what's going on any old time. And I like Climate Reanalyzer, but they rely on the same. They get the data from the same place. NOAA Global Forecast System, GFS, 13-kilometer finite volume cube sphere, dynamic core, FV3 to produce 16-day forecast. So this is medium range. Well, that's actually, I think that's a short range forecast, 16-day. Medium range is like in months or something like that. NCAR, command language. So this is the same data everybody else has, but the reason I like this is because, and this map doesn't move, you can't hit play or any of that bullshit, but it's sort of, you get a snapshot, which is really all I want to see. You know, when my phone always messes up, I look at the radar and it wants to show me a forecast or something like that, and it jumps around and stuff and just drives me nuts. I'd rather just see, you know, from the past up to where we are now, or just see where we are now, and you can see where we are now. There's a big heat dome up here in northern Siberia. So, in a cold spot right up here, right off of Baffin Island, right to the west of Baffin Island. Yeah, so it's just north of Manitoba, just west of Hudson Bay. A little cold spot, right centered right there. And we've got anomalously cool temperatures over Florida. And when you look at this map, and right across the equator, there's a lot of nominal temperatures. I mean, it's kind of a mixed bag, but, it is what it is. We've got fires burning and everything else. Now, real quick, I want to touch on commodities. This is from ABC Australia, and oil is down 2.5%. Iron ore is down 0.5%. Wheat is down 1%. With the Delta variant coming back, and we're in a surge. There was concern about overheating of the economy and that we were going to have inflation. And I had postulated that that's horseshit, that a lot of the inflationary pressures that we were seeing was actually engineered, phony scarcities. Scarcities that can be controlled by people who have a lot of money just by jamming up how freight is delivered. If you can jam up shipping traffic, it was, that ship got stuck in the Suez Canal and stuff. Now, I don't know. I'm not going to say that was a conspiracy or, that was intentional. I don't know that, I'm not going to say that. But, Amazon does had a tendency, I don't know if they still do it or not, to take entire warehouses full of perfectly good saleable items and destroy them to maintain a scarcity so that they can maintain their profit margin. Because, you don't just want to give stuff away and have perfectly good merchandise on the street. You end up with a glut and your prices crash. So they prefer to take the stuff and just smash it. Well, they're not the only people who do that. There's a lot of games that get played, and it's all about scarcity. The XL pipeline, is it really? I've seen Republicans are the ones who, I'd like to maintain some political neutrality, really, because it's not productive to even really talk about politics, because there's shit going on that sort of rises above politics, in my opinion. But it's good for American oil companies. It's good for American frackers for there to be a choke point between the tar sands in Canada and the refiners. So they're introducing a choke point between where the oil comes from, which is Canadian tar sands, and the refiners in Louisiana and Texas. So it elevates it keeps the price of oil higher. It's an artificial scarcity with the stamp of environmentalism on it. So in the oil industry, they're terrible. That's where that's where most of the carbon comes from, is leaks and oil exploration and infrastructure. They're just leaking methane gas right into the atmosphere, which turns instantly into, on its way up, it produces a whole bunch of ozone, and it turns into carbon dioxide and water on the way up. So, in any case, that's where we're at. Commodity prices are going down, and this guy's got a worried look on his face. I'll put the link in the description so you can look at it yourself. And, it's just really, it's always important to me to think like Warren Buffett or somebody like that. Whenever you see these guys, they're very pragmatic. Big-time investors are very pragmatic, and they never get their panties in a twist about anything. They don't worry about shit, because every challenge is an opportunity, right? Every challenge is an opportunity. And living in the United States, we have ways and means to survive. A lot better than in other places. China is having their ass handed to them right now. Their fleets are out like fishing out territorial waters of places like Peru, because they have to. They had a massive, which is still around, by the way. It's a African swine flu, killed 500 million pigs in China last year, or year before last, before the pandemic hit. And so there were people like Ted Yoho. I saw a video with Ted Yoho and another dude where they were talking about that they thought there was going to be a protein shortage. And, a big chicken coop in Florida burned down this past year and killed like 1 million birds. Right? It was a big, North Florida chicken coop. I've had a friend one time that was sent out to bulldoze to move a pile of chicken shit that was like 3 stories tall or something like that. So we raise a lot of chickens. So Florida's an agricultural state. We've got more cows than just about anybody else, and chickens and everything else. But when I heard that a chicken coop with 1 million chickens in it burned down, I'm like, yeah. And I heard other things about, bird flus and swine flu and shit like that, which it comes from Africa, the African swine flu. They're worried about that coming here to the United States and killing a bunch of pigs here. So, we're always keeping our radar out for stuff like that. That's why you have the National Institutes of Health and things like that. That's what they're there for. With all due respect to Governor DeSantis, the governor of Arkansas, I think, signed some stuff into law, and now he's openly saying, yeah, well, I'm hoping now that I signed this horrendous, anti-mandate thing into law, that the courts in our, will overturn it. And that's a bad spot to be in. The Arona K Iris Faye is not gonna, is gonna get worse before it gets better. And I have nieces, nephews, and stepchildren and stuff like that are grown. But I would be paying attention. If I had children, I would be paying attention to what's going on. And I'm not going to say much more about that. But, I find that it's better not to, demonize people. Even Donald Trump. You know what I mean? He's so easy to demonize. It makes it easy to demonize the guy. One-on-one, he's probably, I don't know, he might be a complete asshole. You know what I'm saying? I don't know, though. I don't know. So I think it's important not to demonize people and always speak to someone's better angels. You know what I'm saying? But there are a lot of people who are a lot of people out there who are super duper pissed off about some of the stuff going on out there. But we have the National Institutes of Health and all the disease, all the facilities that we have out there to monitor diseases. We have that shit for a reason. And we have not had a bad pandemic in 100 years because of that. Look at the X-Files or any other, it's been in the public consciousness that when a disease comes to town, these dudes in pressure suits show up and say, remain calm. Where do you think that came from? You know what I mean? Why was that in the public consciousness? Because it's real shit. It's real shit, and it's actually can do a lot of damage and be very inconvenient for a lot of people. So, in closing, the thing that works, that has worked for thousands of years for pandemics, is wearing a mask, social distancing, wash your hands. That's what's always worked. Whether you have a vaccine or you don't have a vaccine or blah, 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 that's what works. Wear a mask, social distance, wash your hands. That's how they did it 1,000 years ago. That's how they did it when they didn't have shit in the Polish ghettos during World War II, I think. They had an outbreak of something. And they kept everybody alive by getting them to wear a mask and wash their hands and social distance. Because that's how it's done. That's how you stop a pandemic. That's how you stop a pandemic. Whether you got a vaccine or not. So we can work this out. You know, everybody can just wear PPE wherever they go. And it'll just be a thing for a while until we get past this. You know, this is the worm is getting ready to turn on all this politicization, whatever, on all the political gamery with the pandemic. The worm's getting ready to turn on that, and it's not going to be good. It's not going to be, whoever's playing games on either side of that shit, it's not going to be, the outcome's not going to be friendly, because people are pissed off already, and they're going to get more pissed off. And rightly so. So let's do the right thing. Get it done. Don't panic. That's where I was going with the whole, you know, Warren Buffett. Those guys don't panic. Look at the data. Take care of yourself. Take care of your family. Do the right thing. You can survive by taking care of your realm. Take care of your realm, and don't worry about the noise. It's just noise. A lot of times, you know, keep it in the road. Do what you got to do. And that's all. I love you guys. Be well. Take care of yourselves. If you haven't been vaccinated, by all means, get vaccinated. It helps. Just from my opinion, you know, do it how you want to do it. Do it how you want to do it. Ham radio's good to have. You know, emergency stuff. Get your emergency shit together. I'm just waiting for God in the machine to show up, and it seems to be. And that's it. Love you guys. Thanks. See you. 1,000 parts per million there. Million there. 600 parts per million there. Now, it's virtually showing the same data. I mean, right? So, in other words, the second to the last is 418. It's 418, right? The second to the last placement on the legend is the same, 418 in both places, right? 419. I can pull it up a little better. You know, 419 and 600, and this one is 418 and 1,000. So I don't have an explanation for that. It's not necessarily that big of a deal, because you're essentially seeing the same data. So does it really matter whether it's 600 parts per million? I mean, reporting the extreme gets them to do, if they're off base, which, you know, I mean, this is a European Space Agency, you know what I'm saying? They spent a lot of money to put this thing together, and they cross-reference between satellite data and balloon data and aircraft data and everything else. So, but, yeah, that's weird.